Hi, I'm Ms. Boom. Today we're going to look at selections, or in other words, combinations. Let's say we pick two student monitors for the class. Does it matter if I pick Alice and Brian or Brian and Alice? No, it doesn't. It's like picking the same it's the same choice. It's one choice. So when we pick AB, it's the same as BA. We call these combinations. So it happens when order doesn't matter. Notice that in the previous video when we did permutations and we lined things up, for example to pick captain and vice captain, then Alice and Brian would be different to Brian and Alice because one person will be first, the other person will be second. In today's video, we're doing the types of questions where we're picking two people to do something, and because we're picking two people to do something at the same time, it doesn't matter if we pick Alice and Brian or Brian and Alice, it's the same choice. So in today's video, we're going to look at when order doesn't matter, when AB is the same as BA. If you're going to do all the types of questions together, when you want to identify whether it's related to today's topic or the previous topic, all you have to ask yourself is AB the same as BA? If the answer is yes, then it's got to do with today's video. If the answer is no, and AB is different to BA, then it's got to do with permutations. So let's have a look. What is the number of arrangements if you had 5 people, Alice, Brian, Cecilia, Dan, and Emily, and you had to pick two class monitors? So there's 2 spaces. To simplify things, I'm always going to use the word objects as things we can pick from, and spaces as how many things to choose we get to choose. So we have 5 things and 2 spaces. Previously, we said that it will be 5 times 4. Which is 20. But today, when the order doesn't matter, when AB is the same as BA, we can see that these two are the same choice. So then we have to divide by these 2, or in other words, 2 factorial. So we get just 10. And I can highlight these in blue to show you that there's 4, 3, 2, 1. There's 10 different choices, and these are just repetitions of those. So when order doesn't matter, you only have 10. You have less combinations. So example 2, if you had 4 ice cream flavors and you have a cone that fits 3 scoops of different flavors, how many different ways can you pick 3 scoops? So we have 4 objects and the number of spaces is 3. And now we have to see how many different variations are there. Well, we can see that previously we would have done 4 times 3 times 2, which is 24. But today, knowing that the order doesn't matter, for example, apricot, blueberry, and chocolate is the same as blueberry, chocolate, and apricot is the same as CBA, ABC, BCA. We can see that we can't just divide by 3 and obtain 8 because these 3 flavors are repeated more than 3 times. We can see that these 3 flavors are actually repeated 3 factorial times. So ABC is the same as ACB, BAC, BCA, 3 CBA, and CAB. We've done this before. So if I look over here, I can see that there are only 4 different ways of picking 3 flavors of ice cream out of the 4. ABC, ABD, ACD, BCD. If I look at any other option here, it's one of these 4. For example, BAC, that's the same as ABC in a different order. So when order doesn't matter, we do 4 times 3 times 2 divided by the number of spaces factorial, because we're dividing by the same objects in different orders, because we don't care what the order is. Let's try to find a formula for this. So previously we knew 4 times 3 times 2, but now we have to also do divided by the space factorial. So how do we do that? Well, the 4 times 3 times 2 is 4p3, or in other words, 4 factorial over 4 minus 3 factorial. This is in a previous video called permutations. So today we're adding in the divided by 3 factorial. Let's just check that it gives us the same answer as 4. So 4 over 4 minus 3 is 1 factorial and 3 factorial. 4 factorial can be written as 4 times 3 factorial, so it cancels out with the 3 factorial and we're left with 4. So this is the right formula. What do we call this? This is called combinations, and it's represented by 4C3. So C is when the order doesn't matter. P is when the order matters. So to obtain C, we do 4P3 divided by the number of spaces factorial. And the formula looks very similar, but now we have an extra R factorial or spaces factorial at the bottom. So let's write this out. So if I had NC3, that would be n factorial over n minus r factorial times r factorial. So this r factorial makes a difference to the permutations. Memorize this formula and try to understand it. So n factorial is if we had unlimited numbers of things in order, and then we divide by n minus r factorial for the missing spaces, and now we're dividing by r factorial for the different orders because we couldn't care about the order. Let's travel through time and start from the beginning so that we can link everything we've learned so far. So we started off with factorial, where we had 5 objects and we just arranged them, and it was 5 factorial or n factorial. Then we talked about permutations, when we had 5 objects but we had limited number of space, and in that example we had to divide by the missing spaces to cancel out the 3, 2, 1, like so, dividing by the missing spaces, n minus r factorial. And today we're looking at combinations. This is like permutations, but we don't care about the order. So now we have an extra r factorial in the denominator to eliminate the different orders. Another way to represent NCR is using these giant brackets over here, where the number of objects is at the top and the number of spaces is at the bottom. This and this are the same thing. Let's do an example. So if I have 5C2, what would that look like? It would look like 5 factorial over 5 minus 2 factorial times 2 factorial. In other words, 5 factorial over 3 factorial, 2 factorial, and we can cancel out the 3 factorials, and 4 divided by 2 is 2, so 5 times 2 is 10. We could also have questions that are 10C3 written in this format. So again, that will be n, that will be r, so 10 factorial over 10 minus 3 factorial, 3 factorial, 10 factorial, 10 minus 3 is 7 factorial, and then 3 factorial. Now we cancel out the 7 factorial, and we can also do 9 divided by 3 is 3, so 3 times 10 times 8 is 120. Example 4, how many ways can you choose 2 donuts from these 8 different flavored ones? So it doesn't matter if I chose what the order is. So we have 8 objects and the number of spaces is 2, and we don't care about the order, so we're not doing NPR, we're doing NCR, where n is 8 and r is 2. Let's plug that in. So we have 8 factorial over 8 minus 2 factorial times 2 factorial, which is 8 over 6 and times 2. The 8 becomes 8 times 7 times 6 factorial, cancel out the 6 factorial, and then 8 divided by 2 is 4, 4 times 7 is 28. Example 5, how many ways can you choose these 3 donuts out of these 16 different flavors? Again, it doesn't matter what the order is, so we're doing NCR, not NPR. So n is 16, there's 16 objects, and we're choosing 3, so r is 3. So 16C3, we have 16 factorial over 16 minus 3 factorial times 3 factorial, which simplifies to be 6, the 13 can cancel, and now putting that in the calculator, we have 560 different combinations. Example 6, how many ways can you choose a committee of 4? Again, order doesn't matter if you're picking 4 people out of a group. We can see that there are 21 people. Again, I'm always going to use the word objects just to simplify my calculations. And we have a space of 4. So we have 21C4, and you can use a calculator or you can simplify. And the number of different combinations is 5,985. Example 7, what if we picked a committee of 2? So we'll do the same thing. The order doesn't matter. It'll be 21C2. So 21 minus 2, we have 19 factorial. Cancel that out. This one's a little bit simpler to to calculate. It's 210. What happens if the order does matter? What would the question look like and what would the solution look like? So if I picked a group of 2 people out of a big group, the order doesn't matter. But if I had to choose a captain and a vice captain or different roles, then the order does matter. In this case, we would use NPR. So 21P2. So we're not dividing by the 2 factorial this time, and we would have a lot more different combination of 2 people, without order, with order. Let's find some patterns. 99C1, what does that equal to? That would be 99 factorial over 99 minus 1, which is 98 factorial. And we know that 99 factorial is 99 times 98 factorial. So the 98 factorial will cancel out, and what are you left with? 99. So 99C1 is 99. What about 11C0? That would be 11 factorial over 11 minus 0, which is just 11 factorial. And 11 over 11 factorial is 1. What about 9C9? You can always pause the video and try this yourselves first. So we have 9 factorial over 9 minus 9 factorial times 9 factorial. 9 minus 9 is 0 factorial, and recall that 0 factorial is equal to 1. And 9 factorial over 9 factorial is also equal to 1. So 9C9 is equal to 1. What about 9C8? That'll be 9 factorial over 9 minus 8 factorial. That becomes 1. And there's an 8 factorial there. And the 8 factorial and 8 factorial can cancel out. So we're left with just 9. So we can summarize this by looking at when r is 0, 1, n or n minus 1. And we can see that when r is 0, we obtain 1. When r is 1, we obtain n. When r is n, we obtain 1. And when r is n minus 1, we also obtain n. So memorize these 4. So the 0 and the n is 1, and the 1 and minus 1 is n. And also memorize np0, which was 1, and np1, which was n. Memorize these 4, and I'll test you next time I see you. Example 10. How many ways can you choose 3 donuts and 2 cupcakes? So this goes back to our first lesson using the word and. Do you remember what and or means? Okay, so to choose 3 donuts and 2 cupcakes. Here we have 8 donuts, so there are 8 objects, and we're looking for a space of 3. 2 cupcakes. We have the n is 6 and r is 2. And the word and means times. And we don't care about the order because we're picking 3 things out of this bunch. So 8C3, and means times, 6C2. And we can evaluate that on the CAS calculator to get 71. Thank you for watching, and I'll see you next time. Bye!